My name is Dana. I will be your host. And today our guest is the ever so lovely Carl Bickmore. Hello, Carl. How are you?
Oh, I'm well. I'm ever so lovely. Well, then you must be lovely too. Thank you.
We'll both be lovely.
All right.
All right. Exciting topic today. The importance of zero trust for DoD contractors.
Yeah, this is like a lot of things that we've seen come through tech. It's a bit of a buzzword these days that's starting to gain steam.
Mm-hmm. So our first question is, what is the zero trust model?
Oh, okay. Well, like you might find out there from vendor to vendor, they have different definitions of the word of cloud computing, for instance, or other things that you might find out there. This is one of those ones that you might find different people have a different term or what they mean different things. To me, at the most fundamental level, a zero trust means that whether something is in your network or out of your network, if it's going to access any resources for your organization, it must be expressly forbidden except when expressly approved. Meaning, rather than the traditional model that happens in networking where everything is accessible except what's blocked, everything is blocked except what's accessible, if that makes sense.
That makes sense.
So nothing is allowed except what is 100% identified and known.
Okay. All right. So how are traditional networks typically set up when it comes to access?
Well, I think it's not just networks, but it's computer operating systems as well. I mean, I think the zero trust model applies in a couple of different ways. Like you'll find out there folks talking about zero trust networking access or ZTNA, or zero trust as an application control on an individual computer. And both computers and networks were originally created to simply do what they can do. In fact, security measures in general are always really just putting up blockades to make sure it's done securely. But by the default nature, if you go into an organization and plug a laptop into a port and that port is connected to a switch, that switch is connected to the network and the rest of the firewall data and the rest of the servers and workstations and also the internet, by default, everything is allowed. There is nothing restricted whatsoever. The original intention of the design of these things was, how do I make it functional and high performing? So this new model that's coming about is realizing how drastically risky that can be when, for instance, on a computer, any application, script, or browser add-on can run, or within a network, any device or remote user can make its way into the network and then have no restrictions in getting around. A really common approach, for instance, to remote access is to connect to a VPN first. And then once you get that VPN access into a network, you can get anywhere in the network, like your computer that just plugged into a port in the building, no restriction. Zero trust would take a different approach that says, okay, even if I'm going to let you in, I'm going to double check who you are through a couple of different things. Like, do you have good antivirus? Do I actually really know who you are? Do I have multi-factor authentication? There's checks on your identity. But then after you get into the network, you're still only going places expressly for you are approved. That way, it's actually higher performing because you're not spreading as wide of a net, but also it's way more secure because even if you connect to the VPN in this scenario or the replacement of VPN, the ZTNA solution, you still can only get to a specific allowed application or a specific folder or a specific area, and all the rest is protected from anything you might introduce to that network. So you can imagine the level of protection here goes up considerably when you consider how traditional networks set up, essentially being wide open. If the initial protection on the perimeter doesn't stop somebody from coming in, then they can run rampant in the network.
So that's a very good point in talking about how these systems were designed, right? They were designed for functionality and performance, and now we have to protect them. So it's the afterthought of things. But that's very interesting in the whole. That's obviously a big difference between zero trust and just letting anybody and everybody in. So thank you for that.
Sometimes when I'm referring to customers, I call it's reversing the default mode of operation. Instead of everything being allowed and trying to block the bad guys, everything's denied and only allowed what you know to be the good guys.
Mm-hmm. Yeah, we just talked about this the other day, right? It's like the bouncer that doesn't let anybody into the bar.
That's right.
Yeah. Having security inside trying to find out if everyone's behaving themselves.
It's a very similar concept applied to application control like we talked about before, and now applied from a networking perspective of what devices and resources you can access in a network.
Mm-hmm. All right. Can you give viewers an example of how traditional networks work with threats outside of the business?
Oh, yeah. Well, look, I would say that the vast majority of any kind of ransomware attacks or hacking attacks we see today are actually taking advantage of the fact that networks work in a traditional method. And so all they really need to do is break the perimeter, find access through the firewall or through an email or through a web page to the internal network. Then spreading laterally is actually not very difficult. I can tell you we've seen a couple of times when we've looked to onboard a new customer and they've got fully functioning antivirus and even decent versions of it, fully functioning firewall, but attackers had found their way into the network through what I would consider legitimate paths, not legitimate for them, but what an employee might use legitimately for, say, remote access. They found their way in through a compromised password, or even maybe through an exploit, which is a lot more rare. It's usually social engineering that leads to it. But they find their way into the network. And then as soon as we begin to put restrictions on the network and threat detection in place, we find that there's an actor fully functioning, beginning to export data, preparing for their attack. Or sometimes we're coming in after the fact when the attack has happened and we can find evidence that they've been there for 3 months. A zero trust network solution would be a far better protection against that. It's still not detection of somebody in your network, but it's way more comprehensive protection because it's about denying everything no matter what, unless expressly approved, which means that if an attacker got into your network and then tried to, for instance, run a script to go across the network, the ZTNA program would block that traffic. So even if they made it in somehow, in some way, the zero trust model would then prevent further expansion or getting to the goods, if that makes sense. And so, real world examples, well, I think the way that networks are currently designed is one of the primary reasons attackers are successful today, that they have to rely on some pathway into your network, but it doesn't have to be straight to the goods because they can then move laterally. And zero trust networking access or application control in a zero trust model would prevent that lateral movement that actually makes their attack successful.
Now, just real quick, we talked about this a little bit when we talked about the application security. So does this, as far as the end user, the person on the computer, does this cause problems when they are trying to go, before you said that you look at logs before you implement something like this? Is that the similar kind of a thing that you would do in the situation so that when it gets launched, it's not, no one can get into anything?
Oh, yeah. Look, it has to be implemented with care, right? You have to really make sure that the restrictions are correctly. It is still a bouncer. Now, instead of a bouncer for your computer, it's a bouncer for your network. And ideally, you have bouncers in both places, right? Be it on the network or for the computer. But just like anything else, when you implement it, you can make mistakes and lock things up and make people have problems getting their work done. So it does take care. It does take expertise and knowledge in the solution and an ability to count and know exactly what's going on in that organization so that you don't forget or miss something that wasn't maybe noticed or explained or brought up earlier. And so you do want to typically go through some type of parallel deployment where you deploy it, you watch, you look, you validate, you do testing, you prototype, and then when ready, you roll it out across the board. But I could say the good news is if you get it right, the end user's experience with ZTNA is actually typically better because a lot of those technologies are more modern than, say, a VPN remote access. And because of the nature of them not being as comprehensive in what they do, they're typically better performing. And so a lot of folks are actually having a better experience with zero trust networking access because their connection's faster and they have permission to do what they need to do for their work, and they can't accidentally get into areas they didn't mean to, but they can do their work. And so it just feels faster and easier. And so, this is an area where done correctly can be a real win-win as well, particularly on the zero trust networking access. Look, I think the key thing here is that folks and a lot of them have a smaller IT team or maybe even fully outsource their IT. And so they internally just particularly don't understand zero trust. So hopefully this, helps them understand a little bit of the questions they need to ask and who they can go to. But their IT team may not understand the model or may not be familiar with the technology. And it really does come down to having expertise in the tools, delivering it. You got to know things around networking. You got to know things around security. You got to know things around end users and their access. And then the tools that provide zero trust architecture. And so for a lot of them, a great answer is going to be to work with a consultant that specifically understands and knows this, or work with an outsourced provider that has this in their tool bag that they know how to implement and implement well and efficiently and in a cost basis that works for them. I think the biggest thing is just understanding you need to be asking questions about it, and you need to be figuring out when is the right time to look at your network with a zero trust model and what initiatives you can kick off. Maybe you don't do it all now, but there's some really very practical things you can begin right away. You just simply need to have the right IT resource that knows how to do it. Mm-hmm. I think it's just understanding it's a new thing and it's different, right? Even maybe even a buzzword. Somebody may have said, hey, you need to do this, and they don't know what it is. So a little education around it goes a long way. And then understanding that if people keep saying, hey, keep doing this traditional VPN or keep doing this traditional endpoint protection, keep doing it. If they keep doing what they did 10 years ago, that they may not have the best approach appropriate for today's environment. So be asking questions about what new things are being done from a security standpoint with your IT team or your provider, whoever that may be.
Yeah. Well, this was great. This was very, very helpful advice and wisdom and all that. Is there anything else you want to throw out there before we go?
I just throw out there, if you have any questions for the question, you're always welcome to reach out to me directly. You can go to our website, snaptechit.com. So feel free to reach out, LinkedIn, our webpage. We're happy to engage and answer any questions.
All right. Well, thank you very much, Carl, for your time.
Thanks, Dana.
Bye-bye.
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 Thanks, Dana.
Bye-bye.